Welcome to this Broadcom course series on Atomic Automation's cloud integrations. Here we focus on the Airflow integration to support two cloud solutions, Apache Airflow, which we'll refer to simply as Airflow, and Google Cloud Composer, or GCC. The same package, composed of an atomic agent and several objects, supports both. In this overview, we'll address the broader aspects before delving into specifics in later modules. For now, our objective is to make sure that students understand why the Airflow and GCC integrations exist and how they benefit our extended communities. One of the more significant roles of atomic automation is to orchestrate operations across multiple environments, including the cloud, and synchronize these processes with other non-cloud operations, say in ERPs. Instead of relying on cloud workflow management, you can centralize process automation configuration of Atomic and then trigger, monitor, and supervise all in one place. Airflow and GCC workload can then be synchronized with the rest of your operational environments, databases, ERP, and operating systems. You should be able to describe the Airflow integration and explain how it works. The integration is entirely consistent with Atomic configuration methods, and we want to make sure that no stone is left unturned. We describe all the component parts of the integration. Integrating Atomic with Airflow and GCC means deploying an agent you obtain from Marketplace. Once installed, this agent creates two template objects, a connection object and a jobs object, which we use to connect to the environments, trigger DAG jobs, supervise execution from start to finish, and finally retrieve job reports. Our purpose is to externalize cloud-based automation to Atomic. In doing so, we delegate workload execution normally performed by two cloud orchestration solutions, Apache Airflow and Google Cloud Composer, to a platform much better suited for process automation and execution. Normally, you'd build DAG-based workflows that can be interpreted by cloud applications like AWS and Azure. By handing those processes over to Atomic, we're able to synchronize with conventional applications, database, and system operations. It also means supervision and support can be assumed by the ops team. The integration comes in the form of a package, which we download from Marketplace. It contains an agent with the standard Atomic configuration and startup procedures. As soon as the agent connects to the automation engine, it adds two new objects to the repository, a connection object to connect to the cloud platform's REST API, and a jobs object template designed to reference DAG job details. Each time we need to trigger a DAG job, we simply create a new Atomic Airflow job. When the Airflow job runs in Atomic, it triggers the matching DAG job in Airflow, supervises its execution, including any child task, monitors status evolutions, and finally generates a job report. This job can be added to a conventional Atomic workflow, so it's part of an orchestrated process involving other applications, say a database, an ERP, or some other system. Finally, it's worth mentioning that the Airflow integration can run as a containerized application and in a containerized environment. We have two systems, the Atomic Automation host and a dedicated system for the agents. The agent is configured with a simple INI file with the values you'd expect: system, agent name, connection, TLS, and so forth. We start the agents with the UCXJ Airflow Java command. As soon as it connects to the engine via the JCP, a number of template objects are created, one connection and one jobs object. The connection object provides a switch to choose either Airflow or GCC. Assuming we have 4 instances of cloud schedulers, 2 Airflow instances, and 2 GCCs. These instances trigger various processes via DAG workflows in the cloud applications they support, AWS, Azure, and so forth. For each instance, we need to create a connection object in Atomic. We use the con templates and duplicate it as many times as we have instances, in this case 4. Lastly, we create DAG type jobs in Atomic for each corresponding DAG process in either Airflow or GCC. The Atomic jobs include the connection objects based on the target system. When we execute the DAG job in Atomic, it triggers the corresponding DAG workflow in Airflow or GCC over these products' REST APIs. We're able to retrieve the successive statuses, supervise the child processes in the cloud, and finally generate a job reports. In Atomic, this DAG job can be incorporated in workflows and integrated with other non-cloud processes. We touched briefly on the benefits of externalizing Airflow and GCC automation to Atomic. Note that the two integrations are essentially the same, only the authentication mechanisms differ. We'll come back to this. If your cloud operations are currently automated with either one, delegating the workload to Atomic will deliver considerable benefits. The cloud scheduler's role is reduced to storing DAGs and submitting them to the cloud solutions. All other functions, especially those pertaining to sequencing and scheduling, are handed over to Atomic. Airflow and by extension GCC are code-heavy solutions. Scheduling and configuration rely on cron-type logic and require a high level of Python proficiency. Unfortunately, many operations professionals don't usually double up as software engineers, and the use of programming to manage process automation will be foreign to many of us. By contrast, configuration in the Atomic GUI is extremely easy. You build configurations with intuitive interfaces like drag-and-drop workflows, and supervise in simple dashboard-type tools designed natively for operations. Statuses are color-coded, and retrieving a log is done with a basic right-click. From an ops perspective, Atomic seldom requires any knowledge of computer programming of any kind. Externalizing operations to a tool with a high degree of third-party integration means you can synchronize all cloud with non-cloud workloads. Through the use of various agents and job object types, we can build sophisticated configurations involving multiple ERPs, multiple database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workloads. It's all done in one place, since Atomic not only provides native support for SAP, Oracle, SQL Server, FTP servers, REST, and more, but can work in conjunction with powerful monitoring and analytical tools like AI and analytics. All of your cloud and non-cloud jobs can be assembled in a simple workflow and executed in a specific sequence in an entirely event-driven, just-in-time fashion and supervised through single pane of glass type tools. Atomic includes extensive capabilities core to the ops business, which are lacking in Airflow. This includes calendars, weekday, weekend, and holiday differentiation, manual versus cyclical executions, interactive error handling, automated recovery, event handling, status management, load balancing and resource allocation, token-based logical resourcing, notifications via SMS and text messaging, escalation, alarms, and much, much more. Finally, there's the organizational factor. In every organization, the ops side of the business has a dedicated team, and they know their jobs inside and out. As such, cloud operations can be added to their portfolio fairly seamlessly. For them, it's transparent. Cloud teams should not be on the hook for handling the ops side of the Airflow business. They should focus on writing DAGs and not manage on-call schedules, escalation procedures, middle-of-the-night crisis management, or more generally, any sort of supervision. To reinforce this last point, we'd like to present a real-life scenario, which our customer enablement teams delivered as a proof of capability, for which we're offering a simplified version here. In this series of events, we're extracting sales data from an SAP environment, which we upload to a Google Cloud environment. We create a file watcher object in the form of an Atomic event to guarantee that the data is fully uploaded before switching to a Google Cloud platform. Using Atomic and GCC, we import and ingest the data, transform the data so it is usable for our specific purposes, and then load the data to some sort of external environments. We have a timing job running in parallel to keep track of the workload taking place in GCC. Based on the outcome of the GCC processes, we generate a report showing what took place, and finally generate a dashboard on the fly so as to deliver the reported data and outcome.